For you to introduce yourselves. So good afternoon, good evening everyone, rather. Thank you very much for being here with us. I'll introduce myself. My name is Manuel Garcia and I work at the Hacking Center of Everest and I make pen testing. And my name is Álvaro Villaverde. I'm also a pen tester at the Hacking Center of Everest, and I also, well, none of them none of us can do anything else. All right. So we'd like to share with you a challenge. That was the result of a challenge that we undertook. So the result was curious. We just want to share with you how we resolved it. So the challenge came out of an internal pen testing. So we had Windows R server. We could only access it through remote desk. The file copy was disabled, same as the copy paste was disabled. We have to escalate privilege through exploiting vulnerabilities to get those credentials. So that was part of the pen testing as one of our objectives. And then we started to download tools, as any other pen tester would do. We would all download tools. As I said, we were limited because we couldn't copy and paste files. That was disabled feature. So the only thing that we could do was to upload files. Mimic-Up, Power-Up, Watson, we could use any of those tools. But when it came to downloading it, we found another limitation that we didn't know of. So there was a squid in the middle, so the access to GitHub was just blocked. We couldn't download anything from it. And then as well as the apps that we wanted to download, even if they were simply coded, they were being blocked because they were considered to be malicious. So we were trying to download tools, we were getting lots of error messages, and people at the SOC were kind of laughing at us because we could not download any tool. Then we decided to get down to work, and we decided to develop a methodology, a number of tools that we have brought with us to share with you, to teletransport our payload to the inside without them being detected, making them look like trusting files. For that, we set up a local lab mimicking the systems that we had there, that we used there. And I'd like to show them to you. Basically, it was a window machine, such as this one. This is the target machine for our pen testing. We had a Kali machine and then a PC Sense in the middle with a proxy squid and an antivirus with a last signature. So Kali machine represents the web server we are trying to connect to download the tools. If I now want to access a file which is considered to be malicious, I will try to access it and I will not be able to access to it because it is blocked as malware. If I want to access to a clean file, such as this one with a smiley face, it is not blocked, same as any other normal file, any file with PowerShell or the Sherlock comes in with the number of signature that makes it being blocked. So we started to think about it, and then I said, okay, let us teletransport our payload to the inside in a manner that we will not be detected. How did we do it? Well, we just made fragments, base 64, and then we introduced them in files that looked innocent, naive, trustworthy. So we have 3 solution proposals. The first one is very simple. The second one is also simple. The third one is more twisted, so to speak, but it is very, very cool. So solution number 1. This is a quite well-known technique, which is about getting a shellcode, base 64, to fragment it, and to create as many folders as fragments in the shellcode. As you can see here, by adding some limiting elements before, so this ranges from 10 to 31, we may type in letters, number. That creates a number of folders that are zipped. I will show you the demo. So our Kali machine now, we have created a script bus to help us generate it. We have our shellcode and a file that takes the shellcode, fragments it, creates as many folders as fragments, and then those folders are zipped. We launch the script, and that creates a file for us. .zip file that is copied onto the web server so that we can download it from the Windows machine. Now it is already in the Windows server. If we go to Windows 10, we may get it now. If we click on it, we can download it, no problem. It is not detected as malicious. It has the payload that blocked us before. So the idea is PowerShell, download the file, unzip it, and to execute our shellcode. Now let us work in this local folder. The only thing that we would need to do would be, but this is very simple, like 4 lines of code. So we download our zip file. If we go to temp file, we will be sitting there. Next, also with PowerShell, we unzip it. If we unzip it, now we can see that all these folders have been created and they are already arranged in order. What comes next? All those files or folders are listed and will be stored. Now, if we take a look at it, we see that the folders are arranged, and then it has these limiting elements as well. So next would be to join everything and to remove the limiting elements and then to store it in a new variable. So if we have this new variable, everything is together. So now we execute it, and now we should be getting the shell in our Kali machine. There it is. Okay, we are already in the machine. So going back to the presentation, what are the advantages? Zip files are universal files. We can use it in Windows, Linux, any system. The good thing about it is that you can make it with PowerShell 2.0. With any version of PowerShell. Disadvantages: it is a well-known technique. Maximum number of characters per file are 253 plus 3 characters, one of the limiting elements that we included. Hiding the content in a zip file, even if it comes with a password, in this case is not possible because you may click on the file and get to see the content of it. Person making forensics would only have to click on it to see the content. And in proxies, in restricted environments, these type of files are blocked, especially if they come in with a password, because they may be understood to have sensitive information or being malicious right away. If we upload it to Virus Total, no AV machine will detect it. Now moving on to solution number 2. So you see that solution 1 is very simple. You just have to write 4 lines and that's it. But it is a well-known technique. Any system administrator will find out about it. And because it was being blocked in the proxy, and I said, well, proxy HTML, file, JPG. So the next thing that we did was to fragment our shell code and then to include it in the metadata of the image, and to download all that as a single image, to recompose it in the system, all that through PowerShell, so that we could execute our tool. We used Metrepper because all AVs can detect it, but we could include Minicat in the image or anything that you would like to. So now I will show it to you. We have the image. As you've seen in the photograph before, it comes with a copyright, so we have inserted the shell code in several fragments. So next, we go to our window machine, and if we go to this image, we can browse, no problem. It was an image. So an image has gone through the proxy. Anyone who will see it will not mistrust it. So again, 4 lines of PowerShell to download the image, as any browser would do. So we're working with the 10 files. But you may use any other file. You open it, no problem. Next. These 5 or 6 lines. So we get the image, we see where it is, and then we extract metadata. You can do that with PowerShell. And now we have everything in the same root. And now I'll show you all the attributes that an image may have. 287 attributes. So very many places with stored information. You may notice that the first ones are the name, the size, and actually down here, 25 is copyright. If I show here attribute number 1, I can see the size of the image. Attribute number 2 was a tab file. But if I show attribute 25, which was 25, I have a fragment of my shell code. And now I am united or compiling everything under a new variable. And now if I show it, we have it already. We brought it from the image, from the metadata, and now we have compiled it, and now we would execute it. Here we go. So same machine. We are not using a different machine. Next one. Advantages. So if you follow Windows standard, you can only input 1024 characters maximum. Well, advantages, you can input more characters, 1024. So this allows you to input more information. There is a high volume of traffic of images in the proxy, so it is very, very complicated to make forensics. So good thing is you can make that with PowerShell 2.0. So you only need like 4 lines of code. And then disadvantages. You may download the image locally. So if someone wants to make forensic, they will find it easier. And then in terms of images, features are very easily visible. So this technique is kind of borderline, but we were close to what we wanted. If we upload the image to Virus Total, no AV system will detect it. And now I give the floor to Álvaro. But still, we said, okay, we know that we have to download the image, and let us try to do it fileless. So meaning that no files will be downloaded on the hard drive, but on the memory. And then we started to look into how we could do it, and then we realized that shell application, because it accesses the image like if it were the Windows Explorer, required us to download the file. However, with System Drawing, which is the library of SystemNet that you can access through PowerShell, you didn't have to download the image. You can download it from bytes root. So we used invoke web request to download the image as a bytes array. And then we turned it into a memory object. However, properties work differently in the library. And because there was no direct mapping between the properties that we already have and those that would identify the library, we identified everything in PowerShell. We were investigating, and we noticed, we could see that the library used an ID, which is an identifier of a list of property, as well as a length. A length of the content of the property is to be defined, as well as a type that it tells us whether it would be ASCII or Unicode text, or whether it would be only integers or not, and then a value that should be of that type, property item. So we did a number of tests, and then we could see that 1,000 Unicode characters have been written in a data field. So in a field that apparently only takes in dates. And they say, well, this property defines a type of data that we are introducing. But this does not restrict you to the EXIF standard. Even if the EXIF standard defines specific standard, this library ignores it. It is less strict with JPGs than with PNGs. Actually, it is not fully working with JPGs, but when we needed to insert PNG, we just got a PNG, we renamed it as PNG, and then it accepted it. So, and we were very happy. What we did with all that, once we compiled it, was to produce a small script known as Scotty that has given the title of our presentation. It is available in GitHub for you to download it if you want to learn how bad our code is. So it gets a payload base 64. It fragments it, writes it on the image JPG metadata using all the properties. So all the properties, with the exception of 2 and 6, can be used. So we are writing with Unicode, and these formats are not accepted. By default, payload is separated in segments of 1,000 characters. So we have introduced over 6,000 characters in a property. We haven't tested the maximum number of characters that can be inputted. But apparently, that number is very high. At the end of the day, it returns 10 lines that you can use to download and execute the payload. And now let us take a look at the 10 lines that are generated. If we take those 10 lines and then we write them on a text file, we download it and we execute it as if it were a pay shell with the one-liner. So we do exactly the same thing. It would be downloaded in the memory. It would read all the properties. We'll compile them on the base 64, and it will be executed. Exit tool window. We use it to read an image that we stored in payload with Scotty. So none of the properties of the fragments that we used are read. So it gets a bit confused with the property 6, but we are not seeing any of the fragments that are stored in the property. So in 293, we can see the list of properties that we use to store the payload, and then in the 20-something, the fragments of the payload in base 64 are stored. Now I will make a demo how the script will be executed. And now we will be using the Scotty tool to make a shellcode in an image. So we have the good image in the web server with hidden metadata. That is to say, with a shellcode in the actual metadata. Now I am inserting a shellcode in a variable so that you can see the command. Then I will activate execution policy. And then I will change the route of the file. This will get the image. We'll write the payload in the properties, like doc2jpg. Then we will execute the URL of the image so that by the time we execute it, it will generate the 10 lines of code. The URL will be already included. And then we will say that the payload will go through the string variable. That's where we have our payload. It has already been executed, it has already been written, and it is ready. For not complicating ourselves, so in our Kali machine, we introduce an image with the properties written on it. And we will try to read them through SIF. Same image. In Linux, when we try to read it with SIF, it has told us that there was an internal error, and that cannot be read. That does not make it undetectable for forensics, but it makes it more difficult to identify. And you can easily access the image from the Windows server, no problem here. Now we take a look at the image that we have uploaded, and it is just an ordinary image. It is perfectly read, and Scotty loves it. Do you know that in Star Trek they used a dog like an alien, and it went through, no problem? So in the Windows machine, we have Meterpreter, listening, and now we execute the 10 commands that are downloaded with the image, and then it is executed. For a second, the image has been downloaded, but downloaded in the memory, not in the hard drive. It has converted into a bytes network. It has uploaded the library, has turned it into an image object. The properties have been compiled, and everything has been stored in the Spock string variable. If we launch it, very soon now, we will have the Meterpreter session. There it is. So no one has created any session in Meterpreter? So going back to our presentation, so let us see the pros and cons. It is fileless. So forensics is a bit more difficult. It does not comply with the standards, which is a good thing for our action. Therefore, because it is more difficult to detect, it didn't happen here. We would have liked it to have happened, because in some cases, instead of giving you an internal error, it closes itself down. Disadvantages. If we open it with an ordinary image editor, we change it and we save it again, the properties may not survive because the editor may not know how to override them. And for that, we need PowerShell 5.0. You may do it with PowerShell 2.0, but so far we've used PowerShell 5.0. And it is not detected by any AVs either. So this is a really cool solution because it allows you to upload the image to different sites, for instance, the avatar forum, that is to say, reliable places where you want to store it. You may also upload it to the intranet of a company and leave it there and then use it whenever you need it. This takes us to another demo I'd like to show you. If you go to any place where we will have an image with some content, okay, so we inspect the element. I will copy the URL of the image. I'm not showing it because I just want you to see this big photograph of myself. This is just any photograph, okay? Okay, we have the URL with the code that Scotty generated for us for that image. This is not malware. No, we behaved. This is just to say hello to you. Okay, the image has been downloaded. You've seen that? And now Manu will take over. And he will finish the presentation.
Bueno, ya habéis visto la herramienta, qué chula que está.
Okay, we have this already, but we want to improve it. Well, how? By supporting other types of images, such as PNG. Right now, we've worked with JPG. Then the use of multiple images to make the forensics more difficult, even fragmenting it in several images. We make a payload with several images. And another thing that would be great is a full repository of IFSAP in image. Imagine to put a power exploit or a PIRE in images. You download the image locally, and with 4 lines you can start playing. And finally, improve the online payload. So instead of executing 7, 8 lines, do it with less lines, maybe 4. So, thank you very much. So, you have any questions? You can say thank you very much, everybody. Okay. You have gone quite quick. You still have like 20 minutes left. Well, we expect we have many questions. Okay, here we have one hand raised. Hello, I have a question about image compression. What you have mentioned, the tool that we can use it. In any case, you cannot. So when you have image compression, all this changes, and you clean out the metadata, and that's it. Some people do it. Twitter, Facebook, Instagram creates a new image, but other sites like forums that allow you to load an avatar, and they don't modify the image at all. They maintain also the metadata sometimes. So there's a bit of everything. You still can find sites where they might not touch the image at all when you upload it. Now we see the image has been loaded just as it was. No compression, nothing at all. So we have a question from the other room. Have you tried with stenography? I believe you said. We thought about it, but we wanted to focus. Well, stenography is very well known, and we wanted to take a more novel approach. Stenography is more likely to survive changes in size and cuts and all that, but not always. Compression can be invalidated or not, but this is a different compression apart that stenography always requires. You can't use always things that are available in the op system, like PowerShells. And to do it with 4 PowerShell lines and bring it up like I missed that. I have a question, and this is encouragement for a topic for next year. Have you made these multi-file type supports to raise a site with PDF or whatever, embedding things and downloading it as if you were downloading a website or a web page? So what we were thinking is doing this with several lines. Scotty we hope it'll become bigger. Obfuscation framework. More questions? Does it allow you to download files, and Windows trusts the extensions because they don't check the magic words? Why don't you include a file on TXT or a PDF that will leave a normal file after the termination of the file? You add whatever you want to add. Well, I think I may know. You may know. You have some types of file that you mentioned that are the TXT, PDF, images and such. So Windows does not check, not like Linux. It trusts the magic binary numbers of the file to decide what type of file it is, but Windows trusts the extension. So when you have the file, the right file, and you finish the binary, you add the ciphered binary after that, and then you extract it. That could be a solution. It's like put it in a SIF, but without putting it in a SIF, downloading it. Yes, but it would be, well, you would see an image or a PDF extension, but the content would be at the end of the file, after the hex. When you finish the hex of the right file, but the entire payload would be there. Part of it, you can divide it in several files. One of the advantages of this is to make detection difficult. To put it in different areas of the PDF would also be possible, just like we did it with the image using the string. Properties. Right after the binary I'm talking, the hex. If you do that, you could trigger the analysis. Well, you fragment it in 3 PDFs, 3 perfectly healthy PDFs. Yes, you could do it that way too. So after the binary of the PDF finishes, this is acknowledged or recognized by Windows. Yeah, that would be another technique. So that was my question. Another thing, if you are downloading PowerShells in TXT, it could also be detected, but it doesn't do anything malicious. It just opens the image and reads the properties. It doesn't trigger any interpreter signature. With this, maybe we could do a defense. Well, Crisp PowerShell should be something general unless you need it for working reasons. Okay, thank you. You said that you have to jump over a proxy. You described it as a squid. The one we set up here, it was a squid to set up the lab. Did you check whether it's possible to make forwarding and jumping over the proxies serving content with MIME times that are different to the correct ones? As we're talking about loading extensions, you have a MIME type that is not. It's rather to jump over some proxy controls. For example, in PDF, download an image, things like that. This says it's an image, but in actual fact, it's something different. We haven't explored that pathway, but it would be a very good option. Have you tried beyond images with? Have you tried with data that are complex structures like CRL, questions on CCP that go around the infrastructure? Well, we wanted to access here. We're browsing through a proxy. We wanted to use files that are usually sent through a proxy. Images, CRL, you download it through HTTP. Right. We would have to see what support we have. As we have the .NET, we have libraries to access the stored data and process them. That will be another pathway. So, thank you. Any question from the top? Yeah. Did you try have you tried HTTPS? The solution we have includes HTTPS, but I mean for downloading files through a ciphered connection. Well, if the browsing is being analyzed with through HTTPS, it's indifferent. Some companies give you no hope of privacy. Yeah, it's true, precisely because they break the HTTPS ciphering. For this reason, they're trying to stay away from ciphers that do not support expert forward secrecy, because it breaks the HTTPS and it allows them to see what you are browsing. Yes, this was